Okay, in order to do this lesson, you're going to need to write this up here. Okay, 8-man is something you're going to need to remember for the entire unit, and it's also going to help you do better on the exam. Second thing you might see again is this right here, where it says in a neutral atom, the atomic number equals the number of protons and the number of electrons. So what that means is that if an atom is neutral, that means it has the same number of electrons and the same number of protons. Okay, so take a look at this right here. This is your key. Okay, so what does this bottom number right down here mean? According to our key, the bottom number is the atomic number. Okay, so this is atomic number 1. So when it asks you what the element is, you would look at the periodic table, look at atomic number 1, and see that it's hydrogen. And you would write hydrogen. The top number is going to be the atomic mass. Okay? So this has an atomic mass of 1, atomic mass of 2, atomic mass of 3. Some of the questions below, number 4, 5, and 6, it's going to ask you to find the number of neutrons. So you would use the formula up here. The mass number minus your atomic number equals neutrons. The mass number is the top number, the bottom number is the atomic number. So for this particular isotope, you would do 3 minus 1 will give you 2 neutrons. I'm going to let you finish that here. I'm going to do number 7 for you. Okay, on number 7, all we were given were protons. Well, according to APE, the acronym at the top, the atomic number equals the number of protons equals the number of electrons. So what that means is whatever number the protons are, that's how many electrons there are, and that's the atomic number. Or if the atomic number was 15, that's how many protons you would have, and that's how many electrons you would have. So they gave us protons. So protons is the same as electrons. How many electrons would we have? Hopefully you thought 8. And then what would our atomic number be? 8. In order to find the name of the element, you would look at the periodic chart and you would look at atomic number 8. Atomic number 8 is going to be oxygen. So the name of the element is oxygen. The nuclear symbol, the symbol is the letter on the periodic table, and you put O. And to find the atomic mass, right here it says to find the mass, it's the atomic number plus the neutrons. So take your atomic number plus the neutrons, and that will give you your atomic mass. Okay, I'm going to go ahead and let you do the rest below. If you struggle at number 9, because there's a very large number for the mass and the atomic number is very small, it looks different than the ones we did above with very little numbers, but it's actually no different. If you want to, so the bottom is the atomic number, 82, and again up here, the atomic number is the same as protons and electrons. If the atomic number is 82, there's going to be 82 protons, 82 electrons, and you can calculate the rest. You're going to need a calculator to do this side. Relative abundance means how often it's found, okay, what's naturally occurring. So in order to find the average mass of, for example, this is 2 different isotopes, okay? It's not the traditional division. You're not going to divide when you find this average atomic mass, okay? So the relative abundance is given in a percent. So this is found 69.17% in the world. But to put it in your calculator, do 0.6917 times the mass. The mass you leave the same way. Okay, so all you did was move your decimal over 1, 2. So in your calculator, you type 0.6917 times 62.929599 equals, and you get a number 43.52, and then you do the same for the next one. You move the decimal over, so it's 0.3083, and I type that into my calculator, 0.3083 times the mass, 64.927793, and that gave me 20.02. Okay, so this is what's different in this. You're going to add these two, and that will give you your average atomic mass. So the 20.02 plus 43.52, my average atomic mass is 63.54. So you have two more to work out on your own. For this one here, you're moving the decimal over twice, okay? So it's 0.014. And you're multiplying your relative abundance by your mass. Multiply your relative abundance by your mass, do it all the way down. Whatever numbers you get on this side, all you do is add these together, and that will give you your average atomic mass.